All right, guys. So we're going to solve equations that have rational exponents. So let's take a look at number one that we have right here. And you can see that we're trying to solve our x, but it's being raised to the 3/4 power. So this is something new for us. But I want to show you something so that you can think about how we can actually solve this. If we had something like this, let's say I had x to the 1/2, and then I raised it to the second power. Think back to the properties of exponents. What do you do when you have a power to a power? Basically, we have this 1/2, x to the 1/2 being raised to the second power. What do? We multiply. So if I were to multiply this, I would have 1/2 times 2, and that would equal 1. So what do I really get? I just get the x, which is this right here. I just get that by itself. Well, what I really do, 1/2 times 2, didn't I multiply by reciprocal? That's exactly what I did. I multiplied by the reciprocal, and that wound up giving me just x. So that's what we want to do here. We want to do that in problem number one so that we can get the x by itself. So what we're going to do to both sides is raise each side to the reciprocal power. So that means I'm going to have 27 raised to the 4/3, remember reciprocal power, equals x to the 3/4 raised to the reciprocal power. Again, the reason why we're doing that, raising it to the reciprocal, is so that will become 1. Because by properties of exponents, power to power, we multiply, and multiplying reciprocals, which become 1. So then this gives us 27 to the 4/3 is equal to x. And most of the time, we will be able to simplify this value. Remember that 27 raised to the 4/3 is the same thing as saying the cube root of 27 to the 4th, or you can say it like this, basically the cube root of 27 and then raised to the 4th power. Either way, you're going to get the same answer. So if you were to key that into a calculator, you would wind up getting 81. So x is equal to 81. And of course, you could also, plug that back into the original, and you'll see that 81 to the 3/4 gives you 27. So that is equivalent. All right, so let's go ahead and take a look at the next one here. So you can see now that we have some additional things with the exponents, the x being raised to the 3/2. So we want to get this by itself. Notice I didn't highlight this -5 here because the exponent has nothing to do with that. Only the x is being raised to the 3/2 power. So we want to get rid of everything else. Well, how can I do that? I can add 5 first. This is subtraction. And that gives me -5 times x to the 3/2 is equal to, and this is going to be -40. Now I'm going to divide by -5 because this is a multiplication. It's -5 times x to the 3/2. So I divide by -5, and that gives me x to the 3/2 is equal to 8. Now we can do what we did in problem number one, that step. We're going to raise both sides to the reciprocal power. So this will be x to the 3/2 raised to the 2/3, and then we have to raise the other side. So then that gives us x is equal to 8 to the 2/3, which if you go ahead and simplify that, you get 4. So the answer here is x is equal to 4. All right, let's take a look at another one. So you can see with this one, number 3, we have the parentheses and then it's being raised to the 5/3. But that's okay because this whole thing is being raised to the 5/3 to the exponent. So there's nothing to get rid of. You cannot subtract 13 to both sides like this. We cannot do that. So be careful. That's not something we can do. We have to get rid of this exponent first. So we can go ahead and raise both sides to the reciprocal power, which in this case will be 3/5. And then I do that to this side here. So that's going to give me what's left inside. So x plus, let me fix that here. x plus 13. And I keep rewriting these problems wrong here. Let me fix that for you. So now you have 1,024 raised to the 3/5, and that is equal to 64. Again, that's something that you can key in your calculator, and you will get the value of 64. So now we only have one step left. We're going to subtract the 13, because again, we're trying to get the x by itself here. Now it's okay, we can subtract the 13 because we don't have any exponent there. So we have x is equal to 51. So that is the answer for number 3. All right, let's look at this last problem here. So now we have, the parentheses, we get the binomial inside the parentheses being raised to the 3/2, plus we have some other terms here. So this goes with the exponent. So we need to get rid of the other things that are there here. So we need to get rid of the 3 and the -2. Well, I'm going to go ahead and add 2 first, because that's what we really need to do, is add and subtract first. So that's going to give me 648 is equal to 3 times x plus 11 raised to the 3/2. And again, I'll fix this. That doesn't look like a 3. So now we got to get rid of the 3. That's a multiplication here, so we're going to divide both sides by 3, and that's going to give us 216 is equal to x plus 11 raised to the 3/2. Now we can go ahead and raise both sides to the reciprocal power. So this would be 216 raised to the 2/3 is equal to, and then we're going to raise this side, plus 11 to the 3/2 raised to the 2/3. So of course that's going to go, and then you have 216 raised to the 2/3 is equal to x plus 11. Well, what is 216 to the 2/3? That is actually 36 is equal to x plus 11. And then we're going to go ahead and to solve for x, we're going to subtract 11. And then that's going to give us x is equal to 25. And that is it. So hopefully this will help you with solving equations that have rational exponents. And it was kind of following up after we did solving equations that have radicals. So this is like natural progression. And I will see you on the next video.